Okay, so I think in yesterday class, we completed how many topics, guys? I think we completed the VLAN part as well as the trunking part, right?
Trunking just started.
Sorry.
Trunking just started.
Yes. In yesterday class, we discussed about the VLAN part as well as the trunking part, right now? Okay, so we are
Yeah.
continue with the VLAN and trunking. Okay, so guys, see, I already told you what do you mean by LAN. LAN is a group of device, PC, server, router, switches in a single location. So that is called our LAN network, right? In yesterday class, I told you something about the broadcast domain. So I told you now, by the help of VLAN, we can break the broadcast domain at which layer? Layer number 2. At layer number 2. Getting my point, everyone? Tell me,
Yes.
Yes, sir.
what do you mean by broadcast domain? Broadcast domain is the group of device which will receive a broadcast frame, and frame looks like fff.fff dot like that. Getting my point? Let's suppose, for example, if we are talking about this one. So guys, tell me right now, how many broadcast domain is there? How many broadcast domain is there?
There
See,
is
this
three
is
LAN. Three LAN, it means there is three broadcast domain.
3 broadcast domain. So if we are talking about this area, so let's suppose if PC number 1 will generate any packet, this packet will reach on the switch, which will broadcast this towards here and here. Please
Yes.
remember one thing, router never broadcast your broadcasted packet, right? And router never forward your broadcast packet. Getting my point? So this is the broadcast domain 1. Second, this is the broadcast number 2. This is the broadcast number 3, and this is the broadcast number 4.
Okay,
Everyone, I
okay.
hope you guys understand. How many broadcast domain is there?
There is four broadcast domain.
This is the first one. This is the second. This is the third. And this is the fourth. How many broadcast domain? 4 broadcast domain is there. Clear?
It means जितने network उतने ही broadcast domain.
Broadcast domain. No, not network. Let's suppose if we are using here switch. If we are using here switch. तो अगर मैं यहाँ switch use कर रहा हूँ, तो let's suppose if you are using the switch, it means how many broadcast domain is there? 1 or 2?
One.
1. Yes. How many routers are there here?
Two routers.
2 routers. So it means, na, every interface of a router is in different network.
Yes.
Every interface of a router is in how many network? Different network. So
Different
see,
network.
let's suppose on R1. On R1, how many interfaces are there? 1, 2, and 3.
Three interface working. Okay.
So it means on all the 3 interfaces, there are different network.
Yes.
And if there are different network, definitely there is a different broadcast domain. Getting my
Yes.
point? I hope you understand.
Yes. Yes.
A broadcast domain is the group of device which will receive a broadcast frame, this one sent by any of the member. Yes, it means if you have a one broadcast domain, it means if any device will send any broadcast packet, every device which is present and in that broadcast domain will receive that frame. Getting my point? Now, for example, let's suppose if we have scenario like this, it means this is the engineering team, this is the HR team, and this is the sales team. Getting my point? If this engineering team send any packet, any broadcast packet, this packet will reach on the switch. By default, what switch will do? Switch will broadcast this
Broadcast
packet
the
to
packet.
all the interfaces. It means, what is the problem here? Problem is, if engineering department is sending any data, that data will reach in HR department as well as in sales department as well. But HR department and sales department do not need these type of data. Getting my point? But
Yes.
here sales department and HR department is getting these type of data, and there is a congestion over the link. There is a congestion over the link. Getting my point? It means what is happening? There is only one broadcast domain is there at layer number 2. So that's the reason if engineering team is sending any data, that data is forwarded to all the department. Getting my point, everyone? See, what is the issues? Performance issue. Lots of unnecessary broadcast traffic can reduce the network performance. Yes, definitely, because sales and HR department do not need these type of packet, but still HR and sales department is getting these type of packets. So definitely it reduce the performance. In case of security, yes, let's suppose if there is a confidential data. So if IT team is sharing the confidential data with each other, but if these data will reach in sales department as well as in HR department, definitely this is the security concern. Getting my point, everyone? Tell me.
Yes, sir. Yes. Yeah.
Let's suppose if we have a router here, and let's suppose if we, what we do, if we connect three interfaces like this, and if engineering team is sending any packet, source IP is 192.168.1.1, this one, this PC is generating the packet. Destination IP is 192.168.129. It means
Sales
this PC
department.
wants to communicate with
Sales
this PC.
department. Yes.
So what is the source MAC address? Definitely for this PC, who is the default gateway? Who is the default gateway? Router. This is the default gateway. Why? Because every packet will reach from here to here through this router here. So source MAC address is PC1 MAC address and destination MAC address is router MAC address. Getting my point? This packet will reach over the switch. What switch will do? Switch will forward this packet towards the router, and router use this link, because let's suppose this link is a part of uh, this VLAN, and this link is a part of this VLAN. What router will do? Router will forward that packet towards here switch, and again switch will forward here like this. So guys, try to understand there is a problem. Problem is why we are using multiple link, because we have a limited interface. We have a limited interface. So this is the disadvantage. This is the disadvantage. Getting my point, everyone? Let's suppose
But
if
sir, why we need a router here?
basically, see, basically by the help of router we can make communication possible here, but this is not the ideal way. Getting my point? By the help of router, yes, we can make the communication possible, but this is not the ideal way, because we are using here how many interfaces? 3 interfaces here, and we have limited interface on the networking device. So that's the reason this is not the ideal way. Getting my point? Understand? But try
And the
to
layer
understand.
2 and layer 3 is separated here, right?
Sorry?
Layer 2 and layer 3 is separated here, right?
Yes, separated here. If we are talking about this one, let's suppose if this engineering team raised the packet like this, source IP is this 192.168.1.1, destination IP is again 63. Let's suppose this one. Fine. No, not this one. This one. Fine. Source MAC is PC1 MAC address and destination MAC is FFF. It means this PC1 is generating the broadcast packet. If PC1 is generating the broadcast packet, what will happen? This packet will reach over the switch. What switch will do? Again forward through all the interfaces. Getting my point?
Yes.
So what is the problem here? Problem is if engineering team is sending the data here for this PC in its own department, but again this packet is reaching in sales department as well as HR department. Getting my point? So try to understand what is the line. Although we separated the 3 department into 3 subnet, yes, we have 1, 2, 3. These are the 3 different networks. Sachin, please remember, these are the 3 different networks. Fine. But at which layer? Layer number 3. They are still in the same broadcast domain. In which layer? Layer number 2. But what I am telling, at according to the layer number 3, all departments are different, because we already assigned different network ID here. But at layer number 2, There is only one broadcast domain. So that's the reason if engineering team is sending any broadcast data for its own department, but these data will reach in sales as well as in HR department. So the reason is at layer number 2, still we have single broadcast domain. Getting my point, everyone?
Yes.
Again, I did not understand, sir. They are in the
Now,
single broadcast. How come?
Sorry.
They are in single broadcast on a layer 2. Can you just tell again?
Yes, what I am telling in this case, see, this is the engineering team. We assign which network? 192.168.1.0.
1.26,
Here we assign
yeah.
1.64 and there is
64.
1.128. It means
128,
these are the
okay.
different network, right?
Yeah,
Engineering team
correct.
have different and different. But at layer
Yeah.
number 3, yes, these are the different. These are in different network. But at layer number 2, still they are in same broadcast domain.
Okay.
At layer number 2, still they are in same broadcast domain. That's the reason if engineering team is sending any broadcast packet, every department will get that packet. There is no separation at layer number 2.
Okay, because of that we need here a VLAN, because
Yes.
there is only one switch which broadcast the
How come they are in
packets.
single broadcast?
Sorry.
How come they are in single broadcast?
Because it's not a layer 3, a layer 3 switch. That's right.
Yes, this is the layer 2 switch.
Okay,
Here,
okay, all right. So, okay, got it.
now, a switch will not forward traffic between the VLAN, including the broadcast unknown unicast traffic. Yes, yesterday we discussed these things. Switch is not responsible to send your traffic between the VLAN. Between the VLAN. Getting my point? Let's suppose if you want to send the traffic from one VLAN to different VLAN, what is the name of that process? Inter-VLAN routing. What is the name of that process, guys? Inter-VLAN routing. Let's suppose
Other
what
VLAN.
inter-VLAN routing. Fine. Now see, in
Routing
this case,
between that.
in this case, what we are doing? Let's suppose this is the engineering team. We assign these 3 PC in VLAN number 10, these 3 in VLAN number 30, and these 2 in VLAN number 20. It means what I am doing at layer number 2, we are separating all the 3. Now just tell me, Sachin, how many broadcast domain is there now?
One.
There is
One broadcast domain at layer number 2.
Yeah.
one broadcast domain in layer number 2.
Why? We already assigned. We already created 3 VLAN here.
Okay. There is three broadcast domains.
Yes, we
Three
already
broadcast
created
domain.
3 VLAN here on the switch, and these 3 PC is the part of VLAN number 10. These 3 PC is the part of VLAN number 30, and these 2 PC is the part of VLAN number 20. So
Okay,
it means we have how many broadcast domain at layer number 2? 3 broadcast domain.
If we will not create any VLAN, so it will in
Yes,
will be a
single
single
all
broadcast.
the
broadcast.
interface will be a
Yes.
part of VLAN number 1. It means there is a single broadcast domain.
Single broadcast. Okay.
So let's suppose if engineering team is sending any broadcast packet, source IP is this one, destination IP is this one, and source MAC is PC1 MAC address and destination MAC is FFF. It means PC number 1 is generating the broadcast packet. Now, if this broadcast packet will reach on the switch, what switch will do? First of all, switch perform the learning. First task is switch perform the learning. After learning, what switch will do? Switch will check the what is the destination MAC address. Destination MAC address is FFFFF. It means what switch will do? Switch will check I am receiving this packet on which interface? This interface. Then switch will check this interface belongs to which VLAN. Then switch will find this interface belongs to VLAN number 10. What switch will do? Switch will broadcast this packet to all the interfaces which is belonging to VLAN number 10. Which is belonging to VLAN number 10. So it means switch will broadcast is towards here, here, and here. So it means, so see, in this case, what is happening? These department, HR department and sales department is not getting your broadcast packet. But previously, when engineering team is sending any broadcast data, every department is getting that packet, right? But now when we are separating here at layer number 2, then only engineering team is getting these broadcast packet. Getting my point, everyone?
Yes, sir.
See, the switch. What is the point? The switch does not perform inter-VLAN routing. It must send the traffic through the router. This is the point I'm trying to say. If you want to make communication possible in a different VLAN, switch is not able to perform inter-VLAN routing. You can perform the inter-VLAN routing by the help of router. By the help of router. How we can perform the inter-VLAN routing? Definitely we will discuss it. Getting my point, everyone?
Yes,
Yes.
Let's suppose, see, PC number 1 is sending the packet or try to communicate with PC number 2. So guys, this is the engineering team. PC number 1 belongs to which department? Engineering team. And PC number 2 belongs to which department? Sales team. Fine. And PC number 1 is a part of which VLAN, guys? I think VLAN number 10, right?
Okay.
And this is in VLAN number
30.
30. What we can do? What we can do, let's suppose the PC1 is sending the data towards switch. What switch will do? Switch will forward this packet through this link as well, because this link is the part of VLAN number 10. Fine. Router receive it. What router will do? This is in VLAN number 10, this is in VLAN number 20, and this is in VLAN number 30. So what router will do? Router will forward this packet through this VLAN number 30 interface. Fine. And this packet will reach on the PC number 2. But again, I am telling, this is not the
but
correct
router
way.
not broadcast that packet.
Sorry, router will. Yes, router will. Sorry, router will.
Router will not broadcast the packet.
Router will not broadcast the packet. Yes, router will not forward any broadcast packet. Getting my point? But try to understand, this is not the correct way. This is the problem. Problem is we have a limited interface. We have a limited interface. So
They call
we
it
can,
router on a stick, right?
yes, router on a stick.
Yeah. Okay.
Router on a stick. So try to understand, if in this diagram, try to understand if this PC is try to send the data towards PC number 2 by the help of switch. This is not possible.
This is not
Because
possible.
switch is not able to perform inter-VLAN routing. Switch is not able to send your packet from one VLAN to different VLAN. So you must need router.
Okay.
You must need router. Getting my point, everyone?
Yes.
But
Okay.
between switch to switch, if we had a trunk line, we can do that, right?
Yes, between switch to switch, if we have a trunk line, we can do it.
Okay.
VLAN are configured on the switch on per interface basis. Yesterday in class, we discussed these things, right? VLAN are configured on the switch on per interface basis. Logically separate and at layer number 2. It means by the help of VLAN, we can broadcast or we can, separate broadcast domain at layer number 2. Switch do not forward traffic directly between hosts in different VLAN. Yes, in different VLANs, by the help of switch, we cannot perform routing. We cannot forward a packet from one VLAN to different VLAN. Getting my point, everyone? Let's suppose if we have topology like this. If we have topology like this, so how we can configure the VLAN? First of all, just tell me, let's suppose I want to check the VLAN on the switch. How you can check, guys? What is the command? So VLAN brief. What is the command? So VLAN brief. This is the command to check the number of VLANs. I already told you by default, VLAN number 1 is there, and all the interface of the switch is a part of VLAN number 1. All the interface is a part of VLAN number 1. Fine. And these are the by default VLAN. We cannot delete these things. Fine, everyone. What is the command, Sachin, to check the VLAN? So VLAN
brief.
Sir,
can we use this VLAN 1002 to 1003?
No, basically these are we cannot use these things because these are for old technology which we are not using. Fine. And there are some VLAN also which is reserved for the future users. Fine.
Okay.
Now let's suppose on switch 1, if I want to create VLAN number 10 and I want to move 0 by 1 to 0 by 3 in VLAN number 10, what is the command? Let's suppose if this is our topology. This is the topology on switch number 1. This is the switch number 1. Let's suppose if I want to move 0 G by 1 to 3. 1, 2, 1, 2, 3. This one, this one, this one, and this one. Getting my point? These are part of which VLAN?
10.
VLAN number 10. How we can move these part in VLAN number 10? First of all, you need to go in interface mode. First of all, guys, you need to go in interface mode. I told you, na. Basically, VLAN, we can assign the VLAN in per port basis right now or per interface basis. So first of all, we need to move in interface mode. Interface range 1 by 0 to 3. Now switch port mode access, then switch port access VLAN 10. Switch port access VLAN 10. So basically this is the command to move the particular port in particular VLAN.
But before
Getting my
this, we
point?
have to create VLAN.
Yes, let's suppose if you do not create the VLAN, you will getting these type of error. This is not the error, but you will get these type of information. Access VLAN does not exist. What do you mean by it? It means I do not create VLAN number 10 here. VLAN number 10 I do not create here. But when I write this command, automatically it will create VLAN number 10.
Sir, how to give the VLAN 10 a name?
VLAN number 10 name.
A name, like we are
Yes.
giving voice and data.
Yes.
Sir, if we run these commands, it means we no need to create any VLAN. The
Yes,
VLAN
let's
will
suppose-
create automatically.
Yes, it will create automatically. Let's suppose if you want to give the name of the VLAN, first of all, let's suppose this is the switch 1 configuration mode. Here you write VLAN 10. After that, you are in VLAN mode. Okay. So let's suppose you write here name cells or just write exit. Name will configured. Now you can check
So we can.
VLAN brief. When you write the show VLAN brief command, you are able to see the VLAN name along with its name.
Okay, so while using the upper here in the above here on the current screen, instead of saying VLAN 10, I can say VLAN cells. I can use that. Switch port mode access VLAN cells.
Access VLAN
Cells, because we give the name 10 as a cells.
Yes.
See,
In this
basically
command,
when you run this command, na VLAN 10 is configured, but name will not configured. You need to write the name manually here.
Yeah. No. Once I give the names, then can I give this command instead of VLAN 10? I can say sales, engineering, or
Yes,
switch mode.
you can.
Okay. All right.
So basically, this is the command to. I hope everyone understand. This is the command to move these port in particular VLAN. Getting my point, Sachin? Understand, everyone?
Yes, sir.
Now,
Sir, you wanted to show us a demo.
Yes, definitely. See, an access port is a switch port which belongs to a single VLAN and usually connect to end host PC. Yes, basically, what is the access port? Basically, generally, what we are doing, we are connecting our end user or end host like PCs on the access port. Getting my point? Switch port which carry multiple VLAN are called. Sorry, yes, Sachin.
Sir, I want to ask that here write that interface range gigabyte 1/0 to 3. It means there is 3 ports.
Yes, 1 by 0, 2, 3.
Okay. So in below side interface range gigabyte 2/0 to 2. What does it mean?
See, you are telling this one, right? See,
yes.
Check this topology. On VLAN number 20, how many interfaces are there? Z 2 by 1 to 2 by 2.
Two interfaces.
2 interfaces are there. So that's the reason we are writing here, na, 2 by 0
okay.
2.
Okay, we are on
Two.
that switch. Okay.
So see now, we have how many interfaces? Not only two, one, two, and that is
Three,
also
Three
three.
also. Yes, yes.
And here,
These
how many
commands are
interfaces?
reciprocal to
One
this
by
configuration.
yes, we are just doing this configuration. This is our topology, and we are doing this configuration here.
Okay, okay.
Getting my point? Now, so there are, I told you in yesterday class, on switch, there are two types of switch port. First is access and second is trunk port, right? And what do you mean by access port? Basically, access port belongs to single VLAN.
Access port allowed to access the VLAN,
Yes,
network.
on access port, only single VLAN data can travel. Fine. And
Yes.
generally on access port, we are connecting our end users. Fine.
Yes.
And what do you mean by trunk port? Trunk port means which carry multiple VLAN.
VLAN.
Which carry multiple VLAN. That is called trunk port. Getting my point, everyone? Now, see, you are telling how can you configure the name. Let's suppose we configure VLAN number 10. Now you are in which mode? VLAN mode. In VLAN mode, you can just write name engineering.
Okay.
Name engineering. We configure VLAN 20. I write name HR. I configure VLAN 30 and name HR. Getting my
Yes.
point, everyone? This command.
Yes.
Allow recording.
Getting my point, everyone? This command
Yes.
creates a VLAN. In this case, it was already automatically created when we assign the interface. I hope you guys understand. When we are assigning the interface, it was automatically created. But at that time, name was not configured. So by this way, we can configure the name for each and every VLAN. How you can check? This is the command. So VLAN brief. When you write this command, so VLAN brief, see VLAN number 10, 20, and 30. And for every VLAN, there is a name.
Yes.
And we already assigned these interface in VLAN number 10, these interface in VLAN number 20, and these interface in VLAN number 30. Understand, everyone?
Yes.
Yes, sir.
Daniel, are you there?
Yes.
I hope you understand.
Yeah, I'm following.
Okay.
Yes.
Buddhika, I hope.
Yes.
Okay, cool. So let's suppose when we configure the VLAN here, these PC is a part of now VLAN number 10, 20, and 30. It means now if PC number 1 is generating any broadcast packet, that broadcast packet will reach only and only in these department and through this link. It means these department and these department will not get any packet. Will not get any packet. Clear, everyone? Understand? Let's suppose if this department VLAN number 30, VLAN number 30 is sending any packet or any broadcast packet. This packet will reach on the switch. Switch will broadcast it 3x2, 3x3, and 3x0. Getting my point? It means if PC number VLAN number 30 department which sending any types of data, this data will not reach in 10 and 20 VLAN. Getting my point, everyone? Tell me.
So like a switch, does the router also stores CAM data?
CAM data, not CAM data. Router maintain two types of table. First is routing table and second is ARP table. That's all.
That's all.
Yes.
Sir, in this scenario, I think if we connect the router, so it can create a loop, I think.
It can create the loop. Why?
Because switch is connected to router and router is connected to on same switch.
How many interfaces you utilize there? That's the reason we are utilizing three interfaces. Three different interfaces.
Four interface we are using.
Yes. So we are using the three different interfaces for every different VLAN. Getting my point? And that is the disadvantage, Sachin. That is the disadvantage. If we are connecting like this, so this is not the correct way.
Okay,
Getting my point? Because we are wasting our interfaces.
Vesting or interface and vesting or devices also. There is, I
Yes.
think, no need to connect the router.
Yes.
Okay.
Yes. Now, guys, who will answer this question?
How many?
Please raise your hand only, guys.
I don't see my name.
Okay. I will ask one by one.
Six, I think. Yes, 6, sure.
Sure. Okay, Daniel.
How many broadcast domains are here shown in this network?
Daniel,
Broadcast
are you there?
domains.
Romeo.
Five.
Okay. 5. Okay. Who is telling 5? Sandeep.
Yeah.
Okay. Buddhika.
6.
6. Okay. Who is next? Sachin, you join two times.
No,
Okay. Shekhar.
I think it's 5.
5. Guys,
I think 5, sir, because broadcast domain, it means which device is broadcasting the packets, that is called broadcast domain. There is 5 switch.
just give me 1 minute. 1 minute.
Yes, yes, yes.
But there are no VLANs now. You are not we have not said any VLANs. So it's a single VLAN, maybe one broadcast.
Yes, yes, you are also saying right.
You have not mentioned any VLAN. Means
Yes, here is not mentioned any
it's a
VLAN.
native
So it
VLAN,
is
it's a
single
single
broadcast domain.
broadcast. Or 2, because switch does not broadcast.
Yes.
Router does not
The
broadcast.
router
So
does
it's,
not broadcast.
2 broadcasts.
2 broadcasts. I think.
No, broadcast domains are broken by the router ports.
Yeah, so we have 2 routers, it's a 2 broadcasts.
No,
5.
each
because,
port is a separate broadcast domain
because in
of a
all,
router.
in every switch, there is default VLAN.
Yes.
Default VLAN 5.
there are 5.
There is 5 switch.
There are
5
switches,
VLANs
that
are
is-
available. It
yeah,
means
but
5
if
broadcast
they
domain.
have
I
not
think.
mentioned VLANs, no.
But VLAN 1 is default VLAN available
For
already.
everyone. So even if you connect 2 switches, it will be a default VLAN. You can always have a connectivity and it will be the same. It will broadcast from a second VLAN also.
Yes, yes,
I mean,
yes. I think it is single.
it's a single or 2. No, it's a 2 broadcast because 2 routers are there. So it's
Yes, yes.
2 broadcast domains. Even if
broadcast.
VLANs are not configured.
Yes, yes.
No, because a router, each port of a router is a single broadcast domain. So it means the
So
routers
1,
here
2,
has
3,
how
4,
many?
4.
5.
Here 1.
Because
2.
between two routers is one
Okay.
broadcast domain.
Yes,
Okay, this is
everyone.
1. Yeah.
Okay. Now, see, this is the answer.
6. Okay. No,
Got
but
it?
you are not mentioned sir, you are not mentioned VLANs, no?
Yes. I'm not mentioning VLAN here. I just asking how many broadcast domain is there. There is no
Okay, you
concept
mean
of VLAN here right now.
Okay.
I
So
hope
this switch,
everyone got it.
this switch is a single single VLAN. It's a native
Yes.
VLAN 1.
Yes.
This native VLAN 2.
Yes.
Native VLAN 3. Native
Yes.
VLAN 4. Native VLAN 5.
Between the router.
Okay, so between the router, there is also a
Yes.
native
Between the
VLAN
router,
kind of.
there is also one broadcast domain.
Okay. All right.
Got it?
Ooh, yeah. Okay.
Okay. Now moving towards the next question. Sachin, please erase this one. Na? How you are
yeah,
erasing this?
No, I haven't erasing.
No, I'm asking Sachin, how you are writing.
One second, one minute.
No, I am not
I was
writing.
writing, sir. No, I was writing, sir. 1 minute.
Okay. Now, guys, this is the second question. How many broadcast domain are shown in this network domain?
Oh, sorry. Can be that all. Oh, they're not going. Yeah, okay.
1, 2, 3.
What is the question, sir? How many broadcast domains?
No, sir.
are
No.
shown?
1, 2,
5.
4. 4 broadcast domain. There is 4 VLANs.
1, 2, 3, 4, 5.
4. Confirm.
5.
Yes, confirm, sir.
5.
Yes. 5
4.
broadcast domain.
5.
See, this is the answer. Sachin, I
Okay.
think you are forgetting between the routers.
Yes, yes. Router is router to connect it. Yes.
Got it?
Yes,
Now,
sir.
next. What happens when you try to assign a switch interface to a VLAN that doesn't exist?
What happens if you try to
अगर आप
assign a
स्विच पे
switch?
कोई VLAN असाइन कर रहे हो और स्विच पे आपने वो VLAN क्रिएट ही नहीं किया है, फिर क्या होगा?
It will get created. It will get created.
Yes. Exact answer is
Okay. Switch will create VLAN automatically.
yes. Exact answer is B, na?
B. Yes.
B.
Yes. Switch will create VLAN.
Yes. The switch will create the VLAN automatically. Right, na? See, na? You already see, na,
Yes.
these things.
Yes.
Okay,
Yes.
next
Yes.
question. Please think this question, then answer.
धीरेंद्र हे झालेलं आहे कार्ड.
Will receive. Okay.
If PC number 3 send a broadcast
Send
message,
code म्हणतो.
how many device will receive it?
8 device will receive.
VLAN is already configured, guys.
1.
4, 5, 6,
Two,
7,
two,
Please
8,
remember, PC
8.
number 3 is sending the broadcast packet.
2.
8 device will 8 device will receive.
2 devices.
Array,
2
1
devices.
device, 2 device, and 3 device. Only 3 device.
Okay,
Why
there is
eight?
VLAN also. Okay, yes, yes.
So we
There is
already
VLAN
created the
also.
VLAN, and these
Yes,
three
yes.
interface, these 4 interface is a part of VLAN number 10.
Only 2 device, only 3 device can.
Number,
Yes,
I
but
don't see the 3. That's why I could not see. Where is the number 3? Is not there. PC3.
Shubham,
Yes,
it
yes.
says PC3, right?
Which
PC3 is here,
which
sir.
PC3.
That is PC1, right?
VLAN 20.
PC1 is sending the broadcast packet, okay?
Okay.
This is the PC number 2, this is the PC number 3, and this is the
Sir, here
router.
PC3.
My question
Here-
PC3 hai na? If PC3 sends a broadcast
You
message.
asked PC3.
Okay,
You
so
say you have
PC3,
PC3,
sorry,
sir, here.
PC3 is sending the broadcast domain, then how many device will receive it? Then
3.
2. 2.
3
Two.
device will receive. 3
Two
device will
One or
receive the
two,
broadcast
one
message.
PC and one switch.
1
2 devices.
2 PC and 1 router receive the broadcast.
VLAN 20 only has 3 devices connected.
Sir,
This is the
3.
Yeah,
Yes.
router and switch and PC.
Only
other
2.
PC.
2
only
PC
two
and 1
devices
router
will
will receive the broadcast.
got it, everyone.
Yes.
Yeah.
Now next question.
I think it's 8. 8.
3.
8.
100%.
8.
3.
10,
What is the
20,
question?
30,
You
default
create
VLAN
VLAN
1.
10. Question is you create VLAN 10, 20, 30 on the switch. How many VLANs will be there displayed if you run the show VLAN brief command? Guys, see.
4, 4.
I run here
4
show
VLAN.
VLAN brief command.
8.
4 तो है ही नहीं उसमें.
भाई
Okay,
ये
sir,
1
yes.
2 3 4 ये भी तो 4 दिखेंगे
Yes.
ना आपको.
Yes, yes, yes.
Yeah,
5 6
wait,
7
wait.
और ये एक दिखा 8. How many
It's a
VLANs are guys there? Total 8
5
VLANs.
5 plus
1
3.
2 3 4 and these are the 4 also.
5 plus 3, 8.
So don't be confused. Okay, I hope you guys understand these concept, right? Okay. Now, Okay, these things we already discussed. Network topology like this. Yes, guys, see in this diagram, what is happening? Who can tell me? This is engineering department here, and this is engineering department here. It is possible. Let's suppose this engineering department is on different floor and this department on different floor. This is possible in real environment, right? Tell me.
Yeah.
Yes, right.
So this is engineering department here. This is in VLAN number 10. This is in VLAN number 10. Again, 30, 20, and routers is there. How we can communicate between these departments?
We have to
Let's
create
suppose
VLANs on
let's suppose this
both
HR
switch.
department send try to communicate with this engineering department. Fine. This switch will forward the packet. Packet will reach on the switch. What switch will do? Switch will forward it towards the router. What router will do?
One.
Router will forward through this link. Again, reach on the switch. What switch will do? Switch will forward towards the switch and communication will happen. Getting my point? Everyone.
Yeah.
But try to
Sir,
understand.
सर मुझे वो ये राउटर का बहुत कंफ्यूज हो रहा है सर.
Yes, router confuse हो रहा है, अभी खत्म हो जाएगा. But try to understand. That's the reason we are not using router. If we are talking about the trunk port, what do you mean by trunk port? Tell me.
It can accommodate more VLANs.
Sorry?
It can carry information of all VLANs.
All VLAN. In a
It can
small
accommodate
network with
multiple
few
VLANs.
VLANs, it is possible to use a separate interface for each VLAN when we are connecting switch to switch and switch to router. Sachin, I hope you understand this line. Everyone, tell me, yes or no?
Okay.
In a small network, we can do or we can create this type of topology. For every interface, we have different. Let's suppose for this, see this topology. For every interface, for every VLAN, we have different interface here. For every VLAN, we have different interface here. But let's suppose if you have multiple VLAN, when the number of VLAN increases, this is not viable. This is not viable. It will result a wasted of interface. It will result in wasted of interface, and often routers won't have enough interface for each VLAN. Getting my point? That's the reason we have a concept of trunk port, who can carry multiple VLAN data through a single interface.
Okay, means we attach the router for the trunk port.
Sorry, we
attach their we attach router for trunking method.
Let's suppose here how many interfaces are you utilizing? 3 interfaces.
3 interfaces of switch
for
and
each
router.
VLAN, for each VLAN, this interface belongs to VLAN 10, 20, and 30. Getting my point?
Okay,
But
okay.
this is not the viable thing. Fine, because we are wasting multiple interface here. What we will do, what is the exact solution? Instead of using 3 interfaces, we use only one interface or one link. Fine, and we make this link as a trunk link.
Okay.
We make this link as a trunk link.
A trunk link.
So by this way, we can
every VLAN can travel
reduce the wastage of interfaces here.
Yes.
Getting my point, everyone? Tell me.
Yes.
Okay. Now, see this, Sachin. This will be the topology.
Yes.
Now we have only how many interfaces? Only one.
One. Yes.
Fine. So this will be trunk link. This will be trunk link. Clear, everyone?
So we can bind multiple ports into single one virtual one.
Sorry, we can bind multiple. Yes,
multiple links,
I know
yeah.
what I know what are you trying to asking. Let's suppose you are asking ki how this router will segregate these VLAN, right?
Yeah.
So basically, what we will do on this router, we will create sub interfaces. sub interfaces, router on a stick. We will discuss it later. Okay. But what I'm trying to say here, instead of using multiple link between the switches, we use only single link and create this link as a trunk link. Getting my point, everyone? Tell
Yeah.
me. Okay.
Yes.
Now, what is the line? Switch will tag all frame that send over the trunk link. In your study class, I told you, whenever you were sending any data frame, switch perform tagging. Switch perform tagging. But how? I told you nothing is happening in a network automatically. There is logic of protocol. So I told you tagging is performing here by the help of two protocol. First is ISL and second one is .1Q. Everyone understand? So whenever you are sending the data or VLAN frame over the trunk link, trunk perform tagging. Let's suppose this is the data and this data belongs to VLAN number 10. What .1Q will do? .1Q just add the VLAN information here. VLAN information here. So when this data will reach over the next route, next switches, this switch will understand this data belongs to which VLAN. Getting my point, everyone? So this tagging will perform by the help of either .1Q or ISL. Clear, everyone? This allows the receiving switch to know which VLAN the frame belongs to. Everyone, tell me yes or no. Anyone who do not understand this line or this concept? Anyone? If you guys not understand, I will repeat it. Tell me.
Sir, please repeat this.
Okay. So see, Sachin, what I'm trying to say, let's suppose this is switch number 1. This is switch number 2. Fine. Let's suppose this is PC number 1 and this is PC number 2. Again, this is PC number 3. I hope my screen is visible to all of you, right?
Yes, yes, yes.
Okay. Now let's suppose PC number 1 belongs to VLAN number 10, VLAN number 20, VLAN number 10 and VLAN number 20. Anyone have any doubt here till now? Clear? Now, let's suppose this is the trunk link.
Yes.
This is the trunk link.
Yes.
If PC1 is sending the data will reach over the switch.
Yes.
Getting my point?
Yes.
Let's suppose if you are using trunk, here we are using .1Q. .1Q. Fine. So let's suppose when this PC will send the data, this packet will reach on the switch. What switch will do? Switch will check, first of all, switch perform the learning. Switch learn the source details.
Packet, yes.
After learning, switch perform the forwarding decision. Okay, switch will take the forwarding decision. But how? Switch will check, I am receiving this packet on which interface? This interface. And this interface belongs to which VLAN? VLAN number 10.
VLAN 10.
So what switch will do? Switch will forward this packet through all the interfaces which is belong to VLAN number 10, as
yes.
well as trunk link. As well as trunk link. यानी switch दो इंटरफेस से भेजेगा, जितने भी इंटरफेस जो VLAN 10 के मेंबर होंगे और as well as trunk. Getting my point, everyone?
Yes.
So now switch will forward this packet through the trunk link, but try to understand, when switch will forward through the trunk link, switch will perform the tagging. Switch will perform the tagging. Let's suppose Sachin try to understand, if switch will not perform the tagging and if this data will reach on the switch, then how switch will find this data belongs to VLAN number 10 and VLAN number 20? Switch 2 will confuse. And if switch 2 will confuse, definitely switch 2 will not able to perform any types of forwarding decision. Getting my point? So yes, that's the reason whenever switch 1 will forward any data over the trunk link, switch 1 will perform tagging. Switch 1 will perform tagging. What switch 1 will do? This is the original data. If you are using .1Q, in yesterday class I told you, if you are using .1Q, switch add 4 byte extra information. How many byte, guys? 4 byte extra information. So what switch 1 will do? Switch 1 add here 4 byte, and in this 4 byte there is a VLAN 10 information. VLAN tag is there. And when this data will reach over the switch number 2, what switch number 2 will do? Switch number 2, first of all, check this data belongs to which VLAN? VLAN number 10. So now what switch 2 will do? Switch 2 will remove this VLAN tag from this data. Fine. What switch 2 will do? Switch 2 will remove this VLAN tag here from this original data and forward this data through towards VLAN number 30. Okay. So basically, what is the conclusion here? Conclusion is switch number 2 is taking the forwarding decision on the basis of this VLAN tag. This VLAN tag.
Yes.
Getting my point, everyone? I hope you guys understand why tagging is important here.
Yes, sir.
Fine, everyone.
Yeah.
Yes, sir.
So if this tagging will not perform, definitely switch 2 will not perform. Switch 2 will not take any forwarding decision. So guys, I'm telling you the last thing. On switch number 1, when any packet will reach from switch number PC number 1, switch 1 is performing encapsulation. And on switch number 2, what is happening? Decapsulation. Tell me yes or no.
Decapsulation. Yes.
Yes. Basically on switch number 1, switch 1 is adding the VLAN tag, and on switch number 2 is removing the VLAN tag. So that's the reason on switch number 2, decapsulation is happening. On switch number 1, encapsulation is happening. And both encapsulation and decapsulation over the trunk link is happening by the help of either .1Q or ISL.
Yes.
Fine, everyone. And one more thing, please remember this one. Note as a note. If you configure here .1Q and if you configure ISL, is it viable? Everyone, who can tell me the answer?
Yes.
Yes?
Yes. I think so.
Can't communicate.
Okay, this is my homework. Please think and let me know. Fine, we will discuss it. Now, Sachin, if you remember one thing, in yesterday class, I think you told me this one. Trunk port, tagged, access port, untagged, if I'm not wrong.
Yes, yes.
Yes,
Aruba, in Aruba switch, this command operate.
So basically on trunk port, when we are sending the data, that data will be tagged. And when you are sending the data over the access port, that is untagged. That's the reason we are using access port where? Definitely in end user. End user. Now, VLAN tagging. There are two main trunking protocol. I told you now yesterday, ISL and .1Q. Fine. ISL is a old Cisco proprietary protocol created before industry standard this one. IEEE is the industry protocol created by this one. You will probably never use ISL in the real world. Even modern Cisco equipment doesn't support it. For the CCNA, you only need to learn .1Q. But I already told you something about the ISL. But try to understand in real scenario, we are using only .1Q. Getting my point? Why we are using .1Q? In yesterday class, I tell you the answer. Who can tell me the answer?
It's only 4 bytes.
Yes. Basically, if you are using ISL, it adds 30 byte more information with your data. But if you are using .1Q, it adds only 4 bytes. This is the one main reason. Second reason, who can tell me? If you are using ISL, it perform tagging for your native VLAN as well. But .1Q do not perform tagging for your native VLAN. Fine? Tell me.
Yes.
So these are the difference we discuss. Okay. Now we are moving towards this one, Ethernet frame. So basically this is the Ethernet header, Ethernet trailer, and this is the packet. So guys, what is the packet? Preamble, SFD, destination, source, type, and FCS. Basically, this is the Ethernet frame. I hope you guys already discussed these things in OSI model, right? आप लोग OSI model पढ़े हो ना?
Yes.
Tell me yes, no.
Yes.
Okay. So guys, this is the Ethernet header, actual Ethernet header. Fine. Let's suppose if you are using .1Q, so this will be the Ethernet header after .1Q. See, this is the original header, and after the source, what is adding here? .1Q. And what is the size? 4 byte. Getting my point, everyone?
Yes.
Okay. So in .1q is inserted between the source and type. Source and type. Between source and type, there is a .1q field. What is the size? 4 byte. The tag consists of two main fields. In yesterday class, I told you TPID and TCI. Tag protocol identifier and control information. Control information. Tag control information. Clear? Understand, everyone?
Yes.
Tell me. In yesterday class, we discussed now about the .1q.
Yeah.
The TCI consists of, see, this is the .1q frame. This is the .1q frame. See, TPID. If we are talking about the TPID, see, what is the size of TPID? 16 bit.
16 bits.
It always set the value up. यही दिखेगा आपको 0x8100. This indicates that the frame is .1q. I told you na yesterday class. Basically, this
Yes,
field
yes.
told you about which protocol you are using, ISL or .1q. Getting my point, everyone? Tell me. So in .1q,
Yes.
in .1q header or in .1q packet, what you will see? .1q is divided into two parts. First is TPID. What is the size of TPID? 16 bit. And what is the use of
16 bit.
TPID? By the help of TPID, it tells us about which protocol actually you are using, .1q or ISL. So generally you see this value 0x8100. This tells us about what? This is .1q. Fine, everyone. Now, next is, see, this is the next 3-bit. These 3-bit is PCP. Basically, what do you mean by this? This tells us about the class of services. I told you na yesterday class, quality of services. Basically, this field is used for quality of services. This field is used for quality of services. Now, next, this is DEI. DEI. What do you mean by DEI? DEI tells us about what? Used to indicate frame that can drop if a network is congested. If switch 1 is sending any data to switch number 2, if there is any type of congestion, if any packet will drop, this field will indicate if any packet is dropped or not. So basically, what is the size? 1 bit. Please remember this one. And the last one is TCI. Last is TCI. Now, what is the size? 12 bit. In yesterday class, I told you what is the size of VLAN, guys? If you guys remember, 12 bit. What is the size of VLAN? 12 bit. Am I audible to all of you?
Yeah.
Guys, all
Yes,
silent.
Yes, yes, bro.
Okay. So, what is the size of VLAN? 12 bit.
12 bit.
Fine. So
12 bit.
basically, the last 12 bit is tells us about the which VLAN you are using.
VLAN ID.
Fine. So identifies the VLAN the frame belongs to. Size is 12 bit. Fine. To the power 12, 4096. That is the range na, of VLAN. Are tell me. Yes or no?
Yes, yes, yes.
Yes.
Okay. Cisco proprietary ISL also have VLAN range. This one. Because VLAN number 0 and 4094 is reserved. Now, VLAN range. This is the range of VLAN. This is the normal range of VLAN. And guys, this is the extended range of VLAN. VLAN range is divided into two parts. Normal VLAN and extended VLAN. In some older devices cannot use extended VLAN range. However, it's safe to accept the modern switches will support the extended VLAN range. We will discuss it later where we can configure the extended VLAN. Fine. But for your information, I just tell you there are two range of VLAN. First is normal range. Range is 1 to 1005. Extended VLAN range is 10006 to 4094. Getting my point, everyone?
Yes.
Yes.
Now, in same topology, see what is happening? Tell me. If this is VLAN number 10 and this is VLAN number 10, if these department, this is same in same department, but these are on different floor. So let's suppose if this engineering team wants to connect with this one, is it possible? Tell me.
Yes, sir, possible.
Let's suppose if this is the trunk port or trunk link, everyone, then
Yes, of course it is possible.
yes, possible. Let's suppose this is sending the packet. This packet will reach on the switch. What switch will do?
Broadcast.
Broadcast. Let's suppose this is the unicast packet. Then switch
The
will
switch
forward
will
this
all the
packet to
VLAN
the trunk
information
Switch
port
will
as well,
travel
na?
to
switch will broadcast, but
no,
Switch
even
will
unique
forward
packet
this.
will
which
send
port
to
are
will
in VLAN
forward.
10 that will forward the packet only in VLAN 10.
Yes, basically, if this is the trunk link, definitely switch will forward this packet to the trunk link. And finally, this packet will reach on the switch one. And on switch number 1, we already have VLAN number 10. And this VLAN
Yes.
number 10 belongs to this interface. And accordingly, switch number 1 will take the forwarding decision.
Sir, in this condition, can we say the switch will broadcast or switch will unicast?
What I'm telling, this PC is generating the unicast packet, not broadcast packet. Fine. If this packet this PC is generating the unicast, this packet will reach here. What switch number 2 will do? Switch number 2 forward this unicast packet through the trunk link. Finally, packet will reach on the switch. On in switch cam table, there is already entry na
Yes.
about this PC and this PC. And on the basis of this entry, switch number 1 will take the forwarding decision. Clear?
Yes.
Everyone?
Yes.
Yes.
Okay. Now, native VLAN. .1Q has a feature, the native VLAN. ISL do not have this feature. If you guys remember, in yesterday class, I told you if you are using ISL over the trunk, what is the disadvantage? Who can tell me? In yesterday class, I told you.
I have used native VLAN.
Okay. Anyone?
Native VLAN is VLAN 1 is called native VLAN. Default VLAN.
No. What I am asking, this is switch number 1, this is switch number 2, and there is a trunk link. Fine. And here we are using ISL, not .1Q. Then what will be the disadvantage?
And communicate in native VLAN with native VLAN.
Okay. Anyone?
Native VLAN is not supported in ISL.
Sorry.
Native VLAN is not supported in ISL.
Okay. I am asking what will be the disadvantage if you are using here ISL?
Because some services runs on native VLAN. So if you use ISL, the services will not pass through.
Yes, you are telling exactly correct. So try to understand. Let's suppose you know multiple feature or multiple protocol or multiple services is a part of native VLAN, right? Everyone, right? Na switch one. Let's suppose between the switches there are multiple protocol or multiple feature by default exchanging switch 1 and switch 2. Let's suppose DTP packet, VTP packet, CDP packet. There are multiple packet. Fine. And all the packet belongs to which VLAN? Native VLAN. But let's suppose, and you know na ki these packet will exchange, let's suppose after 10 seconds. For example, so it means after 10 seconds, switch 1 is generating this packet, again CDP, again CDP, again CDP. And if you are using ISL, what ISL will do? ISL will perform the tagging even for native VLAN. Even for native VLAN. So try to understand what will happen. Switch 1, switch 2, generating CDP. Here you are using ISL. ISL add 30 byte information and you are sending this packet over the trunk link. It means after every 10 seconds, you are sending the huge amount of data over this trunk link. Definitely this is congestion. I hope you guys understand what is the disadvantage here for the ISL. Everyone, tell me.
Yeah, because
Yes.
of the encapsulation, decapsulation, the packet will drop within 10
Sorry?
seconds. Because of the encapsulation and decapsulation, the packet will drop.
Packet will drop.
I mean, yeah, because of the timeout.
No. Basically, see, let's suppose if you are using ISL and this is switch 1 and switch 2. If you are sending CDP and you know CDP is exchanging between these switches continuously. Okay. So if these are exchanging, it means for every CDP packet, you are attaching 30 byte more extra information here. Okay. And switch 1 and switch 2 is continuously engaging in encapsulation and decapsulation. Tell me yes or no. Yes.
Yes.
So if your device is continuously engaging in encapsulation and decapsulation, it means what? It means CPU utilization of your devices is continuously high. अगर आपका डिवाइस कंटिन्यूअसली इनकैप्सुलेशन और डिकैप्सुलेशन कर रहा है, इसका मतलब सीपीयू यूटिलाइजेशन क्या हो जाएगी? हाई हो जाएगी फॉर एवरी पैकेट. Getting my point, everyone?
Yes.
So that's the reason generally we are not using. Okay, next is the native VLAN is VLAN number 1 by default on all the trunk port. In yesterday class I told you, right? We know na VLAN number 1 by default is a trunk native VLAN. However, this can be manually configured. Yes, we can change the native VLAN. How we can change? We will discuss it. Now, the switch does not add .1Q tag to the frame in the native VLAN. We discuss these things. If you are using ISL add. For every packet ISL add perform tagging. But if you are using .1Q do not perform tagging for every packet for native VLAN. For native VLAN. I hope you guys understand. Clear?
Other VLAN, it perform tagging on
other VLAN. Yes, for other VLAN tagging will perform. I am telling you for native VLAN .1Q do not perform tagging.
Okay.
Fine. When a switch receive an untagged frame on the trunk port, it assumes the frame belongs to the native VLAN. It's very important that the native VLAN matches. What is the point? Switch 1, switch 2. Let's suppose here VLAN number 10 is the native VLAN. VLAN number 10 is the native VLAN. If switch number 2 receive any packet from switch number 1 without tagging, then what switch number 2 will assume? Switch number 2 will assume this frame is A. This frame belongs to native VLAN. That's the reason I'm not getting VLAN tag here. Getting my point? Everyone?
Yes.
Everyone?
Yes.
See, in this scenario, here between switch number 1 and switch number 2, what is the native VLAN? Tell me. VLAN number 10. Fine. Now, this PC generate a packet and this PC belongs to which VLAN, guys? Tell me. VLAN number 10. Fine. This PC generate a packet will reach on the switch. What switch will do? First of all, this switch number 2 will see that this traffic is in the native VLAN, because on switch number 2, who is native VLAN? VLAN number 10. And switch number 2 is receiving the packet from this PC, and this PC itself in VLAN number
10.
So when this switch receives this packet from switch number 2, switch number 2 will see, I am receiving this packet from this PC, but this PC already is a part of which VLAN? Native VLAN. It means this PC do not perform tagging for this packet. Do not perform tagging for this packet and forward this packet towards switch number 1. And switch number 1 receive this packet here. Then what switch number 1 will think? This frame has no VLAN tag. जब स्विच नंबर 1 के पास पहुंचेगा, स्विच नंबर 1 देखेगा कि भाई इसके अंदर VLAN टैग तो है ही नहीं, इसका मतलब ये जो पैकेट मुझे मिला है वो डेफिनेटली किससे बिलोंग कर रहा है? नेटिव VLAN से बिलोंग कर रहा है. Getting my point, everyone? What I am trying to say, when switch number 1 will receive this packet from switch number 2, then switch number 1 will think I am receiving this packet without tagging. It means definitely this packet belongs to native VLAN. Fine, everyone. Tell me.
So native VLAN, it means when one VLAN configured on both switch, that is called native VLAN.
See, basically, native VLAN.
So sometimes you said that VLAN 1 is also native VLAN.
See,
when
what I am telling, by default, VLAN 1 is the native VLAN.
Yes.
You can change the native VLAN, but if you are changing the native VLAN, you should change here and here on both ends.
Okay.
Fine. First thing. And second thing, in real scenarios, generally
you can have
we are
only one native VLAN.
sorry. So see what I am telling, basically in real
You can have only
scenario,
one native VLAN.
generally what we are doing, we are assigning unused port for the native VLAN. Fine. Generally हम VLAN 1 को native VLAN नहीं रखते real scenarios में. Getting my point? Due to security reason. Fine. Now, Sachin, try to understand here, what do you mean by native VLAN? Basically, we assign, let's suppose we configured VLAN 10 as a native VLAN. Fine. And here you are using .1 queue. Fine. So if switch 2 is sending the CDP packet. CDP packet. So switch number 2 is sending the CDP packet towards switch number 1. Fine. So what I'm telling, for CDP packet, .1 queue never perform the tagging because this CDP packet belongs to which VLAN?
VLAN 10.
Native VLAN. So what is the use of native VLAN? There is the only one use of native VLAN. For native VLAN, tagging will not perform. Fine. Tagging will not perform. So when switch number 2 receive the packet from this PC, switch number 2 forward this packet towards switch number 1 without tagging. And when switch number 1 will receive this packet, then switch number 1 will see, check this, I am receiving this packet without tagging. It means this packet belongs to VLAN number 10. Because VLAN number 10 is the native VLAN. Fine. And accordingly, switch number 1 will forward this packet towards destination.
Sir, we have to exclusively tell router that it is a native VLAN, or it will take on itself?
Sorry, where?
Do we have to define exclusively a native VLAN, or it will take as a default automatically?
No, basically default it will take VLAN number 1. Fine. We need to define manually. Let's suppose if I want VLAN number 10 should be the native VLAN. Fine. So we need to define manually. Fine.
How to define manually? What is the command to define?
Yes, I will tell
you.
Please wait. I will tell you. Okay. Even not only this, on router, let's suppose if you are performing inter-VLAN routing and router on a stick, we can define the native VLAN on the router. How? We will discuss it. Fine, everyone. Tell me.
Yes.
Okay. Now, Sachin, try to understand here now. Here, what is the native VLAN?
VLAN number 10 is native VLAN.
On which switch? On switch number 2.
On switch number 2, we have created VLAN 10.
No. What I am asking, on switch number 2, what is native VLAN?
Native VLAN is 10.
On switch number 1, what is native VLAN?
VLAN 30.
Now, see,
So
this PC generate a packet. Everyone, please wait. See, this PC generate a packet. This PC belongs to which VLAN?
10. VLAN 10.
Packet will reach on the switch. Packet will reach on the switch. Switch number 2 will see, I am receiving this packet from VLAN number 10. and VLAN number 10 is the native VLAN on my interface, right? Now, what switch number 2 will do? Switch number 2 do not perform tagging. Switch number 2 do not perform tagging. Everyone,
Tagging,
tell me.
okay.
Yes.
See, na, this traffic is in the native VLAN, so I do not need to perform tagging. So fine,
Tagging.
switch number 2 do not perform tagging. Without tagging, switch number 2 forward this packet towards switch number 1.
Okay. So
Now,
switch number 1 can't forward the packet.
yes,
Because
on switch number 1, what is the native VLAN?
native VLAN is 30 there.
30.
VLAN number 30. But switch number 1 is receiving the packet from switch number 2 without tagging for VLAN number 10. It means there is a misconfusion.
Yes.
So when
So
this
in this
packet will reach
condition,
on the switch 1, the switch number 1 will think this frame has no VLAN tag. It means this packet must belongs to VLAN number 30 because
yes.
on my interface native VLAN is 30. The destination in VLAN number 10, not VLAN number 30. But when switch number 1 will open this packet, switch number 1 will find VLAN is 30. Sorry, VLAN is 10, not 30. So what it will do? It will drop it. It will drop it. So that's the reason I am telling, if you are configuring the native VLAN here, the native VLAN should be match.
So sir, have we to manually tag up to the VLAN?
No, you are not performing manually. You can you can configure native VLAN manually. Yes, we are manually configuring the native VLAN. Getting my point?
Yes, yes.
Everyone?
But yet you have not told us how to configure native VLAN on the
Yes,
router.
yes,
Yeah, or on the
yes.
switch. Yeah.
Yes, I do not tell you how to configure the native VLAN. I'm just telling you the only concept here right now. Okay. After that, I will show you how we can configure the native VLAN. Please wait. Okay.
Okay.
I hope you guys understand what is happening here. If we do not match the native VLAN, packet is dropping here because switch number 1 is, if switch number 1 will receive any packet without tagging, it means switch number 1 will think this packet belongs to native VLAN, but actually switch number 2 is sending VLAN number 10 without tagging, but switch number 1 is expecting what? VLAN 30 without tagging. Getting my point? And that is the misconfusion, and packet switch number 1 will drop this packet. Clear, everyone?
Okay, sir. And if we have to communicate,
yes, you should configure the exact
so
same native VLAN.
So in this condition, switch to have to tag on VLAN 1, VLAN 10.
Yes, on switch number 1, you need to configure the VLAN number 10 as a native VLAN.
Yes, but if we want to communicate in between both VLAN, so I think we have to tag on VLAN 10 without tagging
yes, without
matlab,
tagging. See, first of all, without tagging, you are not able to. But if you are configuring the native VLAN, so on both switches, you need to configure the same native VLAN. Let's suppose, for example, if you are configuring here VLAN number 10 as a native VLAN, you must need to configure VLAN number 10 here. So that's the reason switch number 1 will take the forwarding decision. Otherwise, switch 1 will confuse.
और विदाउट टैगिंग यदि हम टैगिंग करके भेजे तो
टैगिंग करके भेजे मतलब टैग देखो जब भी आपके पास जब ये पैकेट पहुंचेगी और जब भी आप ये मेरा आपका ट्रंक लिंक है, ठीक है, अब जब ट्रंक लिंक पे पैकेट जाएगी तो या तो वो आईएसएल से या फिर वो .1q से, इसी दोनों से तो टैगिंग होगी.
यस
तो अगर आप .1q या आईएसएल तो हम यूज ही नहीं करते, आप .1q से टैगिंग करोगे. अगर आप .1q यूज कर रहे हो और आपने अगर नेटिव वीलन 10 रख रखा है तो नेटिव वीलन के लिए तो ये टैगिंग करेगा ही नहीं.
ओके ओके यस यस
अंडरस्टैंड?
यस and if we will not define this is not native
Yes.
VLAN in this condition.
If you are not, then by default one and communication will happen.
Okay, there is also switch one have also
स्विच 1 और स्विच 2 दोनों के बीच में VLAN नंबर 1
VLAN 1 available है.
VLAN होगा
Yes.
और कम्युनिकेशन होगा.
Yes.
ठीक है,
Yes.
फाइन. ओके.
Can we delete native VLAN 1?
No.
Okay.
Okay. Now This is our topology. Fine, everyone. Please see this topology. Anyone have any confusion? I think this is the topology where we are discussing right now, right? Tell me yes, no.
Yes.
Yes.
Okay.
Yes.
Now, on switch number 1, Z0 by 0, Z0 by 0. It means we are discussing about this interface. Okay.
Yes.
Yeah.
Trunk configuration. See how you can configure the trunk. On it, go in interface 0 by 0. I write command switch port mode trunk. Switch port mode trunk. After writing this command, we are getting error. Command is rejected. Command is rejected. Why? Because the problem is when you are manually configuring the trunk, the rule is before configuring manually trunk, you need to configure the encapsulation protocol. You need to configure the encapsulation protocol. Either you can configure .1q or either you can configure ISL.
Also.
Getting my point, everyone? So switch
Yes.
port trunk encapsulation. After writing encapsulation, I press question mark. Then I got 3 options: .1q, ISL, and negotiate. What is negotiate? We will discuss it later. But we have 2 options, either .1q or either ISL. Everyone. So I select switch port trunk encapsulation .1q. So this is the command to configure the encapsulation over the trunk link. This is the command to configure the encapsulation over the trunk link. Anyone have any doubt? Switch port trunk encapsulation .1q. After configuring the encapsulation, now you can configure the trunk. Now you can configure the trunk, switch port mode trunk. Now it will take this command. But if you are writing this command at the first time, definitely it will not take, because it will ask you and it will tell you, first of all, you need to configure the encapsulation. Getting my point? So basically, this is the command to configure the encapsulation and trunk port. Fine, everyone.
If sir, if we will okay, if we will not write here that switch port trunk encapsulation .1q. So I think it is also taking this command also take switch port mode trunk, and other command is switch port trunk allow. Like this command also available.
No. See, what I'm trying to say, if let's suppose in global configuration mode, you write interface gig 0 by 0, fine.
Yes.
And if in gig 0 by 0, if you are writing switch port mode trunk, you will get error. This is the error. What is the error? You need to configure the encapsulation protocol first. You need to configure the encapsulation protocol first. Then after you can configure the trunk. So that's the reason what we are doing. We configure the encapsulation .1q first. Then after I configure the trunk. Fine. Now, many modern switches do not support ISL. They only support yes. However, switches that do not support both, I am using this example, have a trunk encapsulation auto by default. To manually configure interface trunk port, you must need to configure the encapsulation protocol. Fine. So if you are configuring the trunk manually, first of all, you need to configure the what? Encapsulation protocol. Now, what is the command to check the trunk?
Sir, many time I saw that I do not configure the encapsulation 1q.
See, if you see, yes, I already did this one, but you can do these things in older switches.
Yes,
On
yes.
older switches, you can do.
So I type there that
But on
switch
yes,
port
but
mode trunk, switch port trunk allow,
yes, you can
and
do.
VLAN did this or
Yes,
all.
you on basically on packet traces you can do. Maybe it will take. But on a higher end.
Yes, on packet tracer also it will take.
Yes, maybe. But many times you will get this type of error. First of all, you need to configure the encapsulation protocol. Please remember this one. Okay. Now, how can you check the trunk, guys? Command is show interface trunk. So interface trunk. So see, gig 0 by 0 mode is on. What is the encapsulation? .1q. trunking is enabled, and by default native VLAN is 1. By default native VLAN is 1. Fine, everyone.
What's coming?
And VLAN allowed. All the VLAN is allowed on this trunk. We can modify it, but how we can modify it, we will discuss it later. But right now, all the VLAN is allowed over the trunk. Fine. And this is management domain. See, management domain means first I on switch number 1. We already configured how many VLAN? VLAN 1, 10, and 30. That's the reason these 3 VLAN are there. Fine, everyone. Now, next command is show VLAN brief. By the help of this command, you can check the overall VLAN. We already discussed this. Clear, everyone? Tell me. Okay. See, how can you modify the allowed VLAN? See, on switch number 1, I move in interface 0 by 0. I write here switch port trunk allowed VLAN and I just press question mark. See, there are how many options? Tell me.
5.
1, 2, 3, 4, 5, 6 options as there. Fine. Word. What do you mean by word? VLAN ID of the allowed VLAN when this port is trunking mode. Word means, let's suppose if I want to allowed particular VLAN. Let's suppose there is a VLAN cells. You can write here na allowed VLAN cells. Then cells VLAN will allowed. Getting my point, everyone? So by the help of name of the VLAN, you can allowed or not allowed. Fine. Now, what do you mean by add? What do you mean by add? Who can tell me?
You can add the
Means
port
we
into
need
that VLAN.
to figure right here port VLAN number.
Okay. So see, so first of all, see this command. Switch port trunk allowed VLAN 10 and 30. It means by default, all the VLAN was allowed here. When I run this command, na, see, if you guys remember, all the VLAN is allowed 124095, right? Tell me.
Yeah.
But what I write here, switch port trunk allowed VLAN 10 and 30. So now how many VLANs are allowed? Only 10 and 30. Only 10 and 30. Getting my point, everyone?
So that trunk will only carry 10 and 30.
Yes, trunk will carry only 10 and 30 now.
So other VLAN traffic will be dropped.
The other VLAN traffic must be dropped on the switch. Who will carry that packet?
Okay.
Sir, why we need to put this command switch port trunk allow? When we put that command switch port mode
See,
trunk.
basically, let's suppose if you have a scenario like this, switch 1, switch 2. If you want to restrict any VLAN over the trunk link, let's suppose in my scenario, VLAN 10, 20, and 30 are there. Fine. And I do not want these VLAN in user, VLAN number 20 user can communicate here. So what we can do, we can restrict here VLAN number 20. We just allowed VLAN 10 and 30. Now VLAN 20, if VLAN number 20 wants to communicate here, packet will reach here, switch number 2 will drop this here. Getting my point?
Sir, but this is in this scenario, it is only one side traffic is allowed. What about other side also? If you want, so we have to configure each switch separately.
Sorry, you can, yes, or you need to configure. Yes, I already told you, whenever you are configuring the trunk, this is the interface mode. This is interface based means this is for switch 1, switch 2. You need to configure this command on switch 1, this interface, switch 2, this interface. Fine. Everyone.
Yes.
Sir, better, side by side, if you can show us with the packet flow and creating a live demo. So that will create, we can understand it more better.
I will tell you. This is my topology. This is my topology. Fine. So that's the reason. First of all, I am just explaining the concept here. When all the concept you guys grab, then after I will do the same practical here on this topology, on the same topology. Fine, everyone.
Okay.
If you guys want, I can do at the same time. Okay. Now, see, what is the next? Add here. What is next, guys? Add. What do you mean by add keyword? What do you mean by add keyword?
It means we have to put their
See,
particular number of the VLAN.
Yes, let's suppose on switch number 1, how many VLAN you created here? VLAN 10 and 30? Tell me yes or no? Yes?
Yes.
Now
yes.
I want to add VLAN number 20 here. What I can do? I will run here switch port trunk allowed VLAN add 20. Add 20. Now see how many VLAN are there? 10, 20 and
also available there. 30 also.
I hope you understand by the what is the use of add keyword here. Fine. Now,
yes.
Next is remove. What do you mean by remove? Right now, how many VLAN are there? 10, 20 and 30?
Yes, yes, yes.
If I use a remove 20 keyword, then see how many VLAN are there now?
It will
Only
remove the
10
20 and it will keep 2, 10 and 30. Yeah. Okay.
10 and 30, 20 is removed here from there. So this is the use of remove keyword. Now, switch port trunk allowed VLAN. What do you mean by all VLAN? If I run allowed VLAN all, it means, see, I run here all. How many VLAN are allowed now? All the VLAN. 124094.
Will available here. All.
Yes, all the VLAN, not only available. 124094. All the VLAN is allowed.
Oh, okay.
Can we restrict native VLAN not to allow?
Sorry, can we restrict the native VLAN?
Native VLAN in the command. See, you say
basically,
remove.
yes, you can restrict the native VLAN, but let's suppose VLAN 10 is your native VLAN. Yes, you can restrict it.
What about the default VLAN 1? Can we restrict that as well?
Native VLAN 1, yes, you can do. You can test
by
it.
removing command. We can just add remove command and we can remove that native VLAN from here.
Yes, you can restrict it.
What will be the command for that?
Sorry, what is the same command? I will show you. I will show you. Wait, I will show you. Now, next is accept. Accept means what? What do you mean by accept here?
Except all other VLANs are allowed.
Yes, let's suppose if I am writing here switch port trunk allowed VLAN except 1 to 5 and 10. It means all the VLAN is allowed except 1 to 5 and VLAN number 10.
Yeah.
See na? 6 to 9 is there, 1 to 5 is not there, and VLAN number 10 is not there. Apart from this, every VLAN is allowed there. Fine, everyone.
Okay.
Now, none. None means
no VLANs are allowed.
No VLAN is allowed. See, no VLAN is allowed.
It means this command is not valuable.
Yes, you can say. But for your information, I am telling none means not VLAN.
None.
Fine. Show VLAN brief command shows the access port assigned to each VLAN. Yes. See na, these are the interface and these interface is assigned in which VLAN. Okay. And use the show interface trunk command instead of confirm trunk port. Yes. If you want to check the trunk ports, yes, you can use this command. Clear, everyone? Tell me. See, if I am writing here switch port trunk allowed VLAN 10 and 30, what is the native VLAN? What is the native VLAN? VLAN number 1. For security purpose, it is best to change the native VLAN from an unused VLAN. Sachin, I told you na that thing. Generally,
yes,
VLAN
sir.
number 1 we are not using as the native VLAN in real scenarios for security reason. Fine.
Yes, yes. Yes, sir.
What we have to do?
Sorry, unused VLAN. You can use any VLAN as an unused VLAN.
So how to mark that unused VLAN or?
See, basically, let's suppose for my in my case, in my organization, we are using 1001 as a native VLAN. Okay, so this is the policy for every organization. It depends upon the organization which VLAN they are using as a native VLAN. Okay, this is the security policy for every organization. Okay, but you can use any VLAN. Fine. See here, 1001 is the native VLAN here. in this diagram. Switch port, trunk, native VLAN. So guys, this is the command to change the native VLAN. Everyone, please remember. Switch port, trunk, native VLAN 1001.
Means what?
Sorry?
Switch port trunk native VLAN 101.
1001. This is the command to change the native VLAN. Switch port, trunk, native VLAN 1. When I writing show interface trunk C, what is the native VLAN? 1001.
Switch port trunk native VLAN 10. Okay, so this is a command to change native VLAN, but default VLAN.
Yes. By default, VLAN
Okay.
number 1 is the native VLAN, but you can change
To
the
change-
native VLAN.
Okay,
by this,
okay. Switch
use
port
this
trunk
command.
native VLAN.
Everyone, please write down this.
Sir, you're sending us this PPT file, right?
Okay, I will say.
Because yesterday's PPT was a different also, right? Or it's the same?
I know this is the same. I already
Okay,
said.
okay. Please share that one so that we can go with the audio and PPT together.
Okay, cool.
While we're revising, we can go with together, yeah.
So these are the configuration we did on switch number 1. Same configuration we did on switch number 2. Right? First of all, you need to configure the encapsulation protocol, that is .1Q. Then switch port mode trunk, allowed VLAN 10 and 30. Switch port mode trunk native VLAN 1001. I told you na, on both sides you need to run the same native VLAN. Right? So on switch number 1, we configure which native VLAN? 1001. So on switch number 2, you need to configure which native VLAN? 1001. Clear, everyone?
Sir, if we create VLAN 10, 30, 20 on both switch in this condition, and we do not type this command switch port trunk native VLAN, then then VLAN 1 will be
Yes, then
native
VLAN 1 will
only?
be your native VLAN. No matter how many VLAN you created over the switch, by default VLAN 1 will be the native VLAN.
And this is applicable for all kind of switches, including
Yes.
Cisco, HP, Aruba, whatever.
It is
The
not
native VLAN is
more
one.
necessary, I think, sir. Sir, it is very necessary to put this command native VLAN.
Native VLAN means? See, this
native
command you are
VLAN to
asking,
change is-
switch port trunk native VLAN 1001. You are asking this one?
native VLAN command या command देना बहुत जरूरी है क्या? यदि नहीं दिया तो communication
देखो,
तभी
नहीं
होगा।
दिए तो कोई
security reason के लिए ना।
फॉर सिक्योरिटी रीजन के लिए हम देते हैं। समझो इस बात को, जैसे ये स्विच 1 है, स्विच 2 है, आप ट्रंक चला रहे हो, आपने ये कमांड नहीं दिया, बाय डिफॉल्ट क्या होगी? VLAN 1 आपकी नेटिव VLAN होगी। अब ये
Yes.
बताओ, आप नेटिव VLAN यूज कर रहे हो, ये बात मुझे भी पता है, आपको भी पता है, दूसरे को भी पता है,
हैकर को भी पता है।
हैकर को भी पता है।
So hacker can get in and he can use standard commands to access the all switches.
ऑल स्विचेस। समझ में आया?
जी सर, जी सर।
Okay, so this is the switch number 2. Yes, but one more thing, guys. See, this is switch number 2. On switch number 2, on how many interfaces you need to configure as a trunk? अरे दो interfaces, on 0x0 and on 0x1.
Yes, 0x0.
अरे on 0x0 and 0x1, both switches. Sorry, on both ports.
Yes. Both
So see,
ports, yeah.
on 0x0 I configure this one, and on 0x1 I configure this one. Fine, everything is same. Fine. See, what is the difference? On 0x0, guys, see, what is the native VLAN? 1001. On 0x1, what is the native VLAN? 1001. Same.
Same.
On 0x0, trunk on trunk, what is allowed? 10 and 30.
10 and 30.
And on 0x1, what is allowed? 10, 20 and
30.
Exactly.
One
Fine.
VLAN increase here.
yes.
So the default VLAN is not allowed?
Sorry?
Since you have defined this? Since you have
sorry?
defined allowed 10, 20, 30, so 101 will not travel, 1001?
Native VLAN, no, for native VLAN, you do not need to define it. It by
Okay,
default
yeah,
it
yeah,
will
because
allow.
there is no, it goes without tagging. Okay.
Yes. Okay, this is router on a stick. We will discuss this tomorrow. Fine. Okay, so tomorrow what we will do, guys, we will Okay, wait. Whatever we discussed today, fine, everyone. Whatever we discussed today, we will do the same practical on the same lab. Fine, everyone. Tell me yes or no. Sorry?
EVENG, which
No, I am using GNS because it looks very good.
because many commands on GNS are not working
No.
as EVENG.
For CCNA point of view, every command, most of the command will work. No worry. Fine. Everyone. Buddhika, understand till now?